So for this class, we have another 4 more chapters. So today's I will give you 2 chapters, and the rest, the 2 chapters, is about another advanced economic risk assessment, which is the RULA and also REBA. RULA and REBA is for the posture measurement. So, okay, I share my screen. Okay. Can see my screen, right? Okay. Boleh ya? Alright. So this is about the Snook table. So ada yang pernah guna Snook table atau tahu what is actually the Snook table? Or maybe this is the first time heard about Snook table?
Rasanya first time.
First time. Yeah. Okay. Degree tak belajar Snook table because for this master class, kita bagi more on the advanced economic risk assessment. While a degree maybe on until the initial economic risk assessment and sedikit about RULA and REBA. But for master class, we give more on the advanced economic risk assessment tools. Yeah. Okay. So actually, the Snook tables is designed from Liberty Mutual Research Institute for Safety by Dr. Stover Snook and Dr. Vincent Cirillo. So that's why the Snook itself, the name is come from the developer, which is Dr. Stover Snook. Yeah? And this Snook table, also known as a Liberty Mutual Manual Handling Table. Okay? And these tools can be used only for 3 manual handling application, which is the lifting and lowering, pushing and pulling, and the last one is about carrying. Yeah, actually, this Snook table is direct measurement. Yeah? The table is like this. This is example. For this one is lifting. Yeah, lifting for male. So actually, the Snook table, the difference between male and female, and also there are different table for each activities, which is lifting have one table, lowering also have different table, and carrying also have different table. Okay, so maybe we just proceed direct to the application of this table. Okay, this is the example. This person need to lift the load from the vertical height is 75 centimeter from the floor to the tables in the height is about 115 centimeter, right? 75 plus 40. Betul. Okay. So in using the here is the table. When we would like to use this table, we need to know this one. This is the variable, which is that we have to note here. First is about the gender, because the table is different from the male and also female. That's why we need to choose the table. The first one is based on the gender. Okay, gender. And next is about the horizontal distance. You need to know the h, yeah? The horizontal distance, okay, and then the lifting distance, which is the lifting distance, meanings is the distance from the destination here to the from the origin, to the destination. And then percentage of workers who can perform the task, meaning that how may the percentage of the workers who can perform the task, means that this person is able to do this task. How many percent? Is it about 75% only, or 50% only, or maybe 90% only? And then the vertical distance. Vertical distance is the distance from the floor to the table, the origin, the origin part, or the origin table, where where the load is lifting, the origin place, and then the lifting frequency. So how much frequency the workers need to lift the load. Okay, so this is the 6th variable that you need to know when you would like to use the Snook table. Okay, first kita cuba tadi this one, for these activities. Okay, and the gender is male, right? So this is the gender. The gender, you need to know, this is the table for male, so we need to know the male first, and then after that we need to know the width, this one. Width is horizontal distance. Horizontal distance. This one is 50, right? This is the width. Okay, this is the width. Right? 50, but we don't have 50 here. So we need to choose the value that nearest to the yang dekat dengan 50. Yeah. So the value that nearest to the 50 is 49. So we need to choose this one. For the width, there are only 3, 75, 49 or 34. So you need to choose mana yang the closest to the value. Kalau 50 berarti 49, And then the third one, you need to identify the distance. Okay, we have to see, okay, the distance is 40, right? This is distance. Okay, distance is 40. Jadi di sini for 49 ni dia ada 3. There are 3 distance, which is 76, 51 and also 25. Which one is the closest or the nearest to the 40? 51, right? Compare then 76 and also 25. So we choose 51. Okay, and then the fourth one is about the percentage. As I mentioned before, the percentage workers, the percentage here mean the percent pertains to industrial population. Okay, so usually we choose about 90%. Okay, so we choose here 90. Okay, and the fifth one, after we identify the percent, then we need to identify the lifting height. The lifting height here, as you can see here, is from knuckle to shoulder height. Or I think not shoulder, maybe like from knuckle, dari sini knuckle, to maybe elbow height. Okay, so which one is the nearest one or the closest one? Is knuckle height to shoulder height. Yeah. So, yeah. Okay. So, okay, we choose the knuckle height to shoulder height, and then after that, we see we have to identify the frequency. The frequency here. Frequency here is about 5 minutes. Kalau 5 minutes, kita pilih ni, 5 minutes. Dia kena tengok sini one lift every 5 minutes, right? So kita ambil 5 minutes, so kita boleh tarik garis kat sini. So the maximum acceptable weight of lift for males for this situation is 16 kg. This is the answer. Okay. So this Snook table, the objective of this Snook table is to get the maximum acceptable weight. Yeah, same goes to the Niles lifting equation and also the recommendation weight limit using the guideline. Yeah, the previous the guideline, the ISO guideline that you have you have also already learned in manual handling chapter. Yeah, so we got the maximum acceptable lifting is 16 kg. Okay, so sampai sini do you understand? Any question about this table?
Okay, boleh.
I think this is more simple, lebih simple compare than Niles lifting equation, right? Tapi this one you have to there is limitation actually for this Snook table because kita boleh ni siapa lagi ya? Okay. Because the value kita kena matchkan dengan which one is the value that closest to the scenario or the condition. Yeah, macam tadi macam distance is 40. So kita tak ada 40 dekat sini, we need to choose which one is the value that nearest or closest to the 40, which is the 51. Yeah. Begitu juga dengan condition nak lifting dari knuckle height to shoulder height atau macam this one, this is the lifting from the knuckle height to the elbow only, not a shoulder. Tapi kita cari the worst scenario, the worst scenario. Jadi mana yang paling terdekat dan juga the worst scenario. Jadi compare to from floor level to knuckle height is still minimum, So that's why we need to choose the knuckle height to the shoulder height. So kita cari yang the worst scenario tapi yang lebih dekat kepada condition yang sebenar. Okay, so this is the Snook table. Okay, I also have I also have upload this this form or this all the differences of the table. Ini ada 1, 2, 3, 4, 5, 6, 7, 8, 9. So actually for Snook table there are 9 tables. So the depends on the condition, depends on the activities. So kalau lifting males, so you need to choose table yang lifting males. Kalau female, female. So dia akan different table ni. Okay, lowering male, this is the table. This is the for lowering for females. Push, okay, this is for push male, push female, pull male, pull female, and also the carry, carrying. Okay, so different table for each activities, Okay, so ini contoh yang kedua, iaitu carrying, So, alright. So this is the carrying situation. Okay. This is the table for carrying. This is the table for carrying. Sama, macam tadi step dia. First, we need to know the gender, male. So we have to choose table yang male. Okay. And then carry height is 70. So here is the height. First, we need to choose the height condition. 70 is nearest or closest with the 79. So we choose 79. Okay. And then percentage of workers who can perform the task is about 90%. So kita ambil yang 90%. Dia ada 75, 50, 25 atau 10. And then carrying distance about 10 meter. 10 meter. Yang terdekat dengan 10 meter adalah 8.5 meter carry. So kita pilih yang ini. Lepas tu carrying frequency 45. So 45 minutes is nearest with the 30 minutes. So kalau ada di sini 60, kita ambil yang 60 ya, tapi tak ada sebab the next is 8 hours, terlampau jauh the gap between 45 with the 8 hours, so the nearest one is 30. So kita tarik garis sini. Okay, so here is the recommendation or the maximum acceptable weight limit is about 22 kilogram. Yeah, so macam this is how you can use these tools or this table to determine the maximum acceptable weight limit based on the activities and also based on the gender. Okay. Okay, so maybe after this nanti lepas kelas boleh try this exercise. Ya. Kalau ini lifting, ya, saya bagi contoh lifting juga. So you need to choose lifting tables yang male, and then you need to determine the maximum acceptable weight of lift for this condition. Okay. Okay, any question for this Snook table?
So far okay doktor, mungkin kena try dulu kot.
Nanti lepas kelas ni boleh try ya. Tapi basically for this table is more easier lah. It's easier compared than using the Nios lifting equation is banyak calculation kan. Kalau yang ini hanya guna table tapi memang you need to know all the information, the variable tu. Yeah. Okay. So, yeah. Any question? Cik Amiruddin?
In term of accuracy dia macam mana doktor, sebab this one kita just refer some yang macam tak accurate kan, bila you kena ambil the value yang paling hampir dan sebagainya, that compare to the Nios punya method tu, I think yang tu lagi accurate kot
Betul. Actually for each of the tools have advantage and juga disadvantage lah, dan so depends on how depends on us lah as assessor waktu kita nak buat the ergonomic risk assessment, and then we can choose which one is the tools yang menurut kita yang paling sesuai for the condition and also yang paling accurate lah. So depends on us. Tapi these tools already validate juga this Snook table, ya, dah validate juga dan memang dah publish dan banyak juga dipakailah, diguna. That's why kita banyak pilihan untuk buat ergonomic risk assessment tools ni. Kita banyak pilihan, ya, kita boleh compare juga. Okay, kita dah guna Snook table, berapa dapat recommended weight limit. Maybe after that we can also use the Nios lifting equation. Kalau all the information is complete for do the Nios lifting equation, we know all the variables, we can calculate the Nios lifting equation. We can compare also when we use the Snook table. Selain tu ada lagi MAC, ya, MAC bukan MAC Gladden ya. Nama dia MAC tools ya, MAC ergonomic risk assessment tools juga untuk manual handling. Mac lah, dia seperti chart lah macam tu. Tapi untuk kelas ni kita tak ajarlah untuk Mac. For this class untuk manual handling kita hanya ajar untuk Snook table dan juga Nios lifting equation. If you attend advanced ergonomic risk assessment trained person by DOSH, you akan belajar tu. Mac, Snook table, OWASP, OKRA, banyak, semua advanced ergonomic tools yang boleh dipakai untuk ergonomic trained person di bawah DOSH yang advanced era, semua akan belajar tu. So mana-mana yang attend kursus tu dan dapatkan sijil, bukan sijil maksudnya, dia ergonomic trained person ni dia belum competence macam yang lain ya, macam industrial hygiene dan lain-lain macam tu. Tapi apa yang saya dengar next year kalau tak silap, dia DOS pun akan menjadikan ergonomic ni sebagai competent person. Tapi masih belum ni lah, setakat ni baru ergonomic trained person lah. So kalau nak belajar lagi yang lebih lagi advanced ergonomic era tu, boleh ambil lah untuk ergonomic trained person tu yang advanced era. Yang first initial era dulu, dah lepas initial era baru boleh ambil yang advanced ergonomic era. Okay. So terpulang kita lah, kita nak pilih yang mana, depends on tadi the condition, depends on the task yang mana kan, because different task kadang lain juga ergonomic ergonomic risk assessment terus yang akan dipakai. So terpulang macam mana kita nak yang mana yang kita nak pakai menurut kita yang paling sesuai. Okay, so kalau tak ada question lagi pasal Snook table ni, saya proceed dengan next chapter. Yang ini agak mencabar jugalah sebab calculation. Okay, saya share. Okay, so cost justifying ergonomics improvement. Okay, maybe yang dah pernah dengar ke? Mac maybe dah Mac.
Dah.
Okay, so ini dekat master kita ajar jugalah untuk kita bagi juga this knowledge about the cost justify ergonomics improvement. Usually we heard that ergonomics, when we propose something to our boss about the ergonomics improvement, the first thing that they will comment biasanya adalah ergonomic tu mahal. Mahal, kursi ergonomik pun mahal, meja ergonomik mahal. So how we can prove to our boss, to our management that actually the ergonomics improvement is not costly. We can malah kita boleh dapat keuntungan yang lebih if we implement the ergonomics improvement. So how we can prove it? So biasanya orang nak dengar, orang akan buat if we can prove it using the we calculate about the productivity. Kita boleh bagi the projection is in terms of the cost, the eliminate for the cost and then increase the productivity. So here now we will learn about how we can do the cost justifying ergonomic improvement. Okay, so the lesson outcome of this topic, first you can identify the non-value added tasks and also the motion waste. And then the last, after you can identify that, the non-value added tasks and then the motion waste, you can calculate the productivity impact after the ergonomic intervention program. Okay, so the cost justification is this is related to also the regulatory compliance, health and safety performance, and also the production enhancement. Okay, so in this now we will do the cost justification based on the production enhancement. We already know, we already learn about ergonomic and how ergonomic can be benefit, and then ergonomic has been proven also can remove the pain, can prevent from the musculoskeletal disorder, can provide comfortness for others, for peoples. And this one also after the ergonomics remove the pain and can provide the comfortness, it will indirectly decrease the injury related cost, and then also increase the if already decrease the injury related cost, it will increase the production performance, and also it will lead to the cost saving in other areas including the quality and also the delivery. And how is the relationship between the ergonomics and also the productivity? So actually the productivity improvement are the most effective way to cost justify the ergonomic improvement. And then this productivity can be measured at the workstation level. So it will fit easily into typical cost justification process. And it's also simple to predict and quantify the productivity impact of ergonomic improvement. So how we can prove that this ergonomic can affect the productivity? Actually, for now, we learn for it will affect this ergonomic can affect the productivity by two ways. First is you can eliminate the non-value added tasks, and then the second one, you can reduce the motion waste. Okay, so what is actually the non-value added task or added work? So value added work is actually task and operation that makes the product more valuable to the customer. Meanwhile, the non-value added work is the task and operation that a customer is not willing to pay for and not make the product more valuable to the customer. Okay. We call this as the step analysis. Okay. So this step analysis actually is developed by Human Tech in 2009. This is a tool for motion economy. So meaning that we need to eliminate the non-value added task. Contohnya adalah macam berjalan, ya, walking, reaching. Contoh kalau if we put all the workstation, yeah, if we design the workstation at all the activities can be done there without any walking and all reaching, so it will decrease the motion time, ya. Dia akan mengurangi waktu untuk bergerak. So because time is money, right? Kalau kita ada berjalan, so there is a distance there, and then the operators need to walking to reach the, another workstation contohnya untuk mengambil part and so on, dia kena berjalan. So there ada masa, ada waktu yang terbuang di situ. That is categorized in non-value added task. Kalau kita boleh design part tu tak perlu jauh, tak perlu operator tu berjalan untuk ambil the part. So dalam satu workstation yang sama. Jadi akan menjimatkan masa, ya. Itu salah satu contohnya. And then this step stands for standard time efficiency process, ya. So what is how using the step analysis tool? So in this step is to estimate the motion time saving from ergonomics improvement, and then the improvement reduce, reach or eliminate working step. So the non-value added task here, when we use the step analysis tools, is reach and also reduce the reach and also eliminate the working step. Yeah. Step only can be used for reaching motion, working motion, determining the relative effect of alternative improvement, and estimate the time saving from job improvement after we reduce the reach motion and also we eliminate the walking motion. Okay, so for the step zone, for the reach envelope, yeah, this one is the step zone for reach envelope. Okay, reaching to the fast, so there is some so there is some distance, yeah. This A is the red one, so sampai sini this one is A, yeah. B1 yellow one, maybe yellow one sampai sini, okay. This is B, and then C is the green one, green sampai sini. This is rich envelope, yeah. Okay, and then D here until sampai sini. Sorry. E adalah yang this blue one. Okay, so this is the rich envelope. So we need to eliminate this. If we can reduce the reach from A position to from E position to B or to C, it will reduce the motion time. It will reduce the motion time. Okay. So ini adalah the distance. A is between 0 until 15 centimeter. B is 15 to 30. C 30 to 45, until E is 60 to 75 centimeter, the distance, okay? And next, tadi reach ya, as I mentioned before, for this step analysis, only for two non-value-added tasks, which is the reach envelope and also the walking. So yang tadi adalah for the reach envelope, the penalty. This one is step design and penalty untuk the reach envelope tadi. So kalau the reach envelope-nya adalah between 0 until 15 cm, is this one ya, A area. Okay. Kalau dia letak di antara 0 hingga 15 cm, so the penalty is about 0.2 seconds. Yeah. Penalty ni maksudnya pekerja tu akan menggunakan masa sebanyak 0.2 second untuk reach something that the distance is in area A area. Okay. Kalau B area ni A, this one B, this one C, D, and also E. So kalau B area is 0.4, C 0.6, D 0.8, E is 1 second. Yeah, this is the penalty. Okay. So next is about the working, step penalties for working. Okay. Step analysis assigned to time saving for each step eliminated for working task. So for the first step, kalau ada aktiviti berjalan, the first step we correspond to 0.8 second. Meanwhile, for the subsequent step, so meaning the second step until seterusnya is about 0.5 second. Hanya the first step only yang penalty dia is 0.8 second. The next step is 0.5 second. Okay. And this one is estimating ergonomic improvement benefit or cost recovery. So how we can calculate the productivity impact calculation after we calculate the total time saving. Okay. So the first one is projected productivity impact after we reduce the reach and then we eliminate the walking. So we can calculate the projected productivity impact. Yeah. So total time saving divided total operation time, and then times 100. Yeah. This one is conservative productivity impact. Okay, so from the total time saving times 0.65 divided total operation time, then times 100. Now we can get the productivity calculation. Okay, this is the example. Okay, so we try. This one is the job improvement for reaching. Okay, yang ini yang reaching. Job improvement, kita buat improvement. This is the current step zone. Meaning is the yang ada sekarang, macam the condition, the current step zone. Okay. This job name is secure cartridge tray. Okay. So the job first is install tool balancer. Okay. So the operator atau the person needs to reach from 15 to 30 centimeter area. Okay, kita tengok yang 15 until 30 centimeter tadi, berapa penalty dia? 0.5, right? So kita tulis 0.5. This one is 0.4, 0.5, sorry. Sorry ya, sekejap. .4. Okay. And then reach to 45 to 60 centimeter. Okay. 55 to 60 centimeter is 0.8.
0.8.
Okay. 0.8. And then ini yang current. Yang current, the person need to reach from yang 15.30 kepada 45 ke 60. So this is the condition. And then we propose the improvement. Kita propose something, meaning we propose to reduce the reach distance. Yeah. Macam mana tu? Kita ubah letaknya maybe. Yeah. Maybe we change the position. From yang tadinya asal dia 15 ke 30 cm, so sama the penalty dia 0.5 kan, 0.4 sebab 15 ke 30, reach to tadinya 45 ke 60. 45 ke 60 tu zone mana ya? Zone B. Okay, so we change the position to zone C. Zone C betul? Betul. Zone C 30 ke 45. Penalty dia adalah 0.6. 0.6. Okay. Jadi this one we calculate this one, total dia adalah, saya tulis sini ya. For current, (0.4 plus 0.8, sorry. Dia reach from condition yang zone apa tu? 15.30 zone B. Zone B to zone D kita ubah dari zone kepada zone B to zone C. Okay. So zone B to zone D adalah 1.2. Okay. 1.2. And then propose-nya propose 0.4 to 0.61. Yeah. Ni 1.2 cm, 1 cm. So ada pengurangan jarak we reduce the reach about 0.2 cm. Okay. So how much is the this one is not cm, this one is time, right? Ini bukan cm. Sorry. Ini time. Penalty ni maksudnya time tadi kan, second. So second. Second maksudnya. Second. Okay. So time per cycle ada 2. Okay. 1.2 dengan propose dia adalah 1. So kita boleh jimat masa atau time sebanyak 1.2 minus 1. 0.2 kan? Kita boleh jimat 0.2 second untuk satu cycle yang projected ni. So kerana dia 2 cycle, jadi 0.2 times 2. So 0.4. So ini dia 0.4 the projected. Conservative, kalau conservative ni, this one to calculate the conservative, total time saving time 0.65. Jadi yang tadi 0.4 tadi 0.4 ni time 0.65 dapatlah 0.26. Okay. Begitu juga dengan yang next, yang move part tray to south. So kita kena kira dulu penaltinya untuk kita kena identify dulu yang ini zone A berapa penalty dia, yang this one zone D tadi berapa penaltinya. Sama. Yang ini this one tak ada perubahan. Dia di tempat yang sama. So 0.5 ni kalau saya tak silap tadi 0.2 0.2. Okay. 0.2 ni 0.2 ni 0.2. Yang ini 0.8 berarti 1 minus 0.4 jadi 0.6. Ya. Ni konservatif dia 0.6 times 0.65 sama dengan 0.39. Okay, itu untuk yang rich.
Doktor,
Ya.
soalan. Yang konservatif tu calculation dia ada 0.65 tu 0.65 tu datang daripada mana?
Yang
Sorry
ini.
kalau saya tertinggal.
Tak apa. Yang ini.
Understood in the formula, understood. But
Ya.
how the 0.65
Oh,
tu,
yang how to zero. Okay. As I mentioned before, this calculation is come from previous research ya. Jadi kan yang ini dari Human Tech in 2009. Okay. So before they develop this step analysis, they already do the research and then do the calculation and so on. Okay. So sebetulnya 0.65 ni dapat dari from the research tu lah, the result of the research, the result from their research. So all this formula dan juga dari mana dapat 0.65 is after they do the research. Dia dah buat eksperimen banyak kali. Okay, sampailah dia dapat the model and also sampailah dia dapat calculation ni. Dari situ dapat 0.65 ya cik.
okay. Mean this two formula is come from that study tadi lah.
Betul.
Okay.
Berasal dari Human Tech. Human Tech 2009. Ya. So boleh dicari juga. Begitu juga macam tools-tools yang lain. Contohnya Nios lifting equation kan. Dari mana formula-formula yang dapat HM, VM itu sebetulnya memang from previous research juga, yang mana previous research tu sebelum dia keluarkan semua model ni, calculation, model and so on, they already do all the eksperimen dan juga data analysis the data sampai mereka dapat this is the formula. Okay, so itu tadi untuk yang rich. And then for the walking, for the walking sama juga sebetulnya, but walking kan kita different ya, dia punya penalties. For the first step is 0.8 and current subsequent step is 0.5. So this one, first step is 0.8. Next step ada 8. Maksudnya 8 step. Ya, 8 step. Okay, so kalau 8 step berarti 8 times 0.5. Okay, jadi dapat berapa tu? 4.8 ya? 4. 4.8 kan? Sorry,
Yes,
4. Total 4.8 kan? Okay. Yang ini 4. Oh, betul. Yang ini 4. So totalnya currentnya adalah 0.8 plus 4 equal to 4. Sorry. Sorry. Okay. Ini 0.8. Ini 4 tadi. So current 0.8 plus 4 equal to 4.8. So propose-nya adalah propose 0.8 plus berapa?
1.5.
1.5. Ya. Jadi 2.3. Betul ya? 2.3. Okay. So 4.8 dengan 2.3 jadi projected adalah 2.5. Kalau ada 2 cycle dia kalikan 2 lah times 2. Okay, jadi 5. Tapi sebab ni hanya 1 cycle saja, jadi projectednya adalah 2.5. So konservatif dia adalah 1.63. Okay. Tapi perlu diingat this one is dalam time ya, second. Okay, jangan sampai salah. So ini semua second. Okay. So next apa lagi yang dibuat job improvement, which is the eliminate time. So dia integrate two process ni. Okay. The current method dia perlukan 0.60 second, meaning antara dua activities ni dia buat berasingan. Okay, dia buat berasingan. So that's why ada masa 0.6 yang terpakai sebab dia buat berasingan. So when they do the improvement, they integrate the two process. Meaning that the operator tu buat dua kerja tu sekaligus. So there is no, tak ada tambahan masa lah, zero yang propose ni. Jadi dia jimat projectednya 1.2 second sebab ada 2 cycle. Satu cycle dia akan jimat 0.6 ya. 0.6 sebab 0.6 time kurang kosong jadi 0.6 sebab tu cycle dari 1.2. Okay, so after this you just calculate, tambahkan, dapatlah 4.7 second per unit. Okay, so the total motion time saving is about 4.7 second per unit. Meanwhile, for the conservative way, cara yang current itu, you just can save the motion, the time hanyalah 3.06 second. So dia ada sebanyak 1.64 second per unit. Kalau kita tengok per unit, memang timing ni kecil saja nampaknya, hanya 1.64. But when you do the mass production, contoh mass production, dia akan nampak impact yang besar terhadap productivity tersebut. Okay, ini saya yang ini just bagi yang tadi, ini sama yang tadi ya. Okay, tadi kita dah dapat total motion time saving adalah 4.7 second per unit. Conservative 3.06. Okay, so now the condition, the current cycle time adalah 15 second per unit. Okay, satu unit dia boleh buat selama 15 second. The working time is about 7.5 hours per day per shift. And daily shift ada 2. Okay, ada 2 shift yang buat kerja macam ni. A light job ada 3. Meaning ada 3 workstation yang sama. Pekerjaan dia sama macam ni. So how much is the total time saving per day? Ya, berapa banyak total time saving per day? Sebab ini kita baru dapat total time saving second per unit sahaja, baru per unit. So kita kira, okay, ada 4.7 second per unit, ya. 4.7 second per unit. Okay. And then current cycle time katanya 15 second per unit, meaning 1 minute 4 unit task can be completed. Okay, so time saving in 1 minute 4.7 times 4, jadi 18.8 second. 1 minit kita boleh jimat 18.8 second. Kalau dalam 1 hour kita boleh jimat about 1128 second. Dalam 1 hari 8,460 second. Macam mana pula dengan 1 hari? Okay. 1 hari 2 shift. Ini tadi 1 hari 1 shift baru. And then the next is 1 day 2 shift. Kalau 2 shift buat kerja yang sama, so dia boleh jimat dalam 16,920 second dalam 1 hari. Tapi ini bukan hanya ada 2 shift, tapi ada 3 jobs alike dalam setiap shift tu. Ya. So 16,920 times 3 ada sebanyak 50,760 second per 50,760 second yang boleh kita save the time per hari. Okay, so kita boleh save about 846 minit per day kalau kita buat the ergonomic improvement, the job improvement. Kita boleh jimat masa dalam 846 minit. Meanwhile, kalau kita pakai cara yang current, yang konservatif, dia boleh jimat sebanyak 549.90 second sahaja per day. So banyaknya dia punya different about 300, dalam 300 minit perbezaan dia. Kalau kita gunakan cara yang kita dah projected, maksudnya kita improve dengan cara yang konservatif. Okay. So after that, kita dari motion time saving tadi, how we can calculate guna duit, saving, cost saving. Yes?
ada soalan. Saya cuba back yang satu calculation belakang.
Okay.
Yang kita kira 1 hour tu 18.8 then you time 60 because of 1 hour kan. And then you dapat second, macam mana boleh 60 minutes then dapat second?
Okay. First, sebelum 1 hour kita dah calculate untuk 1 minit, cik. 1 minit kita dapat 18.8 second.
18 second.
Okay. So kalau kita nak calculate untuk 1 hour kan ada 60 minit.
Okay. Pasal 1 minit tak pasal.
Betul.
Okay.
So 60 times 18.8 jadi 1128 second.
60 tu bukan unit dia bukan minit lah, 60 kali tu kan?
Bukan 60 kali.
Okay.
Sebab kita dah calculate dalam minit.
Okay. Faham.
Actually terpulang sebab dia kena samalah unit dia kan. Dia
betul.
boleh jadi kita terus calculate kepada hours dia boleh je. Kan? Tapi sekarang ni kita nak tengok dalam inilah kita samakan unitnya, kita nak dapatkan second, akhirnya memang kita convert juga ke minit lah jadinya supaya nampak besar dia berapa. Okay. Yang ini biasanya kadang sering salah dekat sini. Okay. So kena tengok kalau kita dah calculate 1 hari ni, okay, ini saya just memang detail buatkan step by step, tapi sebetulnya kalau nak terus saja macam contoh ni kan, ni 1 hari 8,460. Terus je kali 2 shift kan, dikalikan 2 shift dikali 3 pun akan dapat 50,760 ya. Ini saya buat macam ni supaya nampak step dia lah one by one, okay. Right. Okay, sekarang kita nak kira duit. Lepas kita dah tahu total time saving per day. Ini kita tadi dapat dalam second, ini sekarang kita dalam minit per day ya. Okay, dan dalam 846 minit tu kalau kita jadikan hour adalah 14.1 hour ya, 14.1 hour. Dalam 1 hari dia boleh jimat 14 jam. 14 jam. Okay. So ini maksudnya pekerja tu sepatut kalau ikutkan pekerja tu ada 14.1 hour lah boleh jimat, masanya dia boleh lepas kita guna yang projected job improvement tadi. Okay. Sedangkan contohnya di sini dia bagi hourly labor rate tu kita kira per hour contohnya ya. Contoh ini adalah company yang pekerjaan dia membayar pekerja tersebut per jam. Okay. Kalau kita tadi boleh saving 14.1 hour dengan cara yang projected tadi, berarti dah mengurangi jam kerja dari pekerja tersebut kan. Jadi kalau kita jadikan duit, kalau kita bayar orang RM12 per hour, lepas tu kita dah jimat masa sebanyak RM14, kita boleh jimat RM169.20 yang boleh kita jimat per day. Patutnya tadinya kita bayar orang sebanyak ni, tapi sebab kita dah buat improvement, kita dah boleh jimat RM169 per hari. Ya. Meanwhile, kalau kita guna conservative way tadi, kita just boleh jimat sebanyak RM109.85 saja. So ada dalam 50 atau RM60 bezanya antara projected tadi dengan conservative way. Okay, sini nampak ya. Tadi adalah duit ya per hari. So macam mana pula dengan productivity? Okay, kalau productivity ni kita biasanya tengok dalam percentage ya. So tadi kita dapat 846 minit ya yang kita boleh jimat. Meanwhile, total operation time per day tadi adalah berapa minit total operation time per day? 7,5 jam. Rasanya per hari kan? Ni 7.5 hours per day per shift. Satu shift 7.5. Lepas tu ini sebab kita project time dalam minit, so kita convert ke minit juga. Ni 7.5 hours times 60, maksudnya dijadikan minit. Dia ada 2 shift, dia ada 3 light job. So ada 2,700 minit yang diperlukan. So pembayar orang company ni bayar orang sebanyak 2,700 minit lah yang untuk dalam satu hari, ya. And then kita calculate the productivity impact. So the projected productivity impact adalah ini dalam minit, ya, kita dah jadikan minit kan, sebab total time saving per day yang kita ada adalah dalam minit. So 846 divided 2,700 times 100%. Jadi sebanyak 31.33% yang boleh dijimat. Increase the productivity. Okay. Kalau konservatif hanyalah 20.37% saja productivity impact dia. So ada dalam 11% bezanya antara projected way dengan conservative way. So 11% tu tinggi kan untuk productivity. So ini macam mana kita boleh buktikan, salah satu cara lah yang boleh digunakan, how we can proven to others that the ergonomic improvement will increase the productivity, and also from this method, this step analysis, we can show the cost, ya, based on the cost yang boleh dijimat macam tu. Okay, so kita ada tadi macam tadi ada ni 846 minit per hari kita boleh jimat. So what to do with the extra time resulting from the ergonomic intervention? Okay, usually production demand is already being made. No need to increase the production. Dengan kita jimat 846 minit tadi, the demand is already made lah. Production tu dah settle dah siap dah. Ada 846 minit yang kita ada masa tu yang kita boleh buat sesuatu. Okay, so apa yang boleh kita lakukan dengan extra time tu? We can do the additional quality check, we can do cleaning the workstation, and then maybe boleh bagi rehat untuk pekerja tu untuk buat stretching and so on. Yeah. This is the example application of step analysis. Ini based on the layout lah. Tadi sebab step analysis dia eliminate the non-edit value task, which is reduce the reach, and also eliminate the working, the motion. Okay, as you can see here, this is the before layout. Yeah. Hello. Ada siapa ni? Okay, so this one is before this company do some innovation, ergonomic improvement. This is the layout. So dari sini 1 ke 2, lepas dah 2 ni dia pergi ke 3, this is the station, lepas tu ke 4, 5-nya di sini, 6, 7, 8, 9 dan 10. So this is very, ada banyak working, excessive working with product, lack of continuous product flow, from this layout. After they do the ergonomics improvement, they use the U-shaped work cells here. Okay, so it improve the product flow. Okay, reduce the prolonged or multiple handling, reduce the walking motion. So the motion saving is about 34.8 seconds per cycle. Yeah. So after they reduce this one, they eliminate the walking motion, they reduce the reach motion. They can save about 34.8 seconds per cycle. So this is another example of application in one company. Yeah, after they do improvement on the layout, and also reduce the non-edit value tasks. Okay. Right. So this is the exercise. So maybe after this class, you can do this exercise. Jadi ada 2 exercise untuk malam ni yang boleh dibuat untuk melatihlah guna yang tadi, the Snook table. The second one here is the cost justifying ergonomics. Question part B-nya, after you determine atau calculate the motion time saving second per unit, so you need also to calculate the total time saving per day. Calculate the total money saving per day, and last is calculate the productivity impact. Okay, any question? Ada pertanyaan untuk yang ni? Harap you boleh faham ya, cost justifying economic improvement ni.
Boleh.
Okay. Any question? Tak ada? Okay. Kalau tak ada, nanti boleh buat the exercise dan submit. Nanti saya open the submission dalam kalam. Ya. Submit paling lewat esok. Boleh?
Okay.
Dr. Mita,
Ya, Natika.
kiranya exercise yang Snook table juga ke? Ke yang
Snook table, dua-dua.
Oh, dua-dua. Okay.
Yes, Snook table dan juga cost justifying ergonomic tadi. Okay, boleh ya? So besok sebelum tahun baru, kena submit dulu exercise. Boleh, Mac?
Beres.
Mac dekat mana tu? Pasar malam?
Kan, dari rumah.
Okay.
Tapi orang sebelah ni, buat hal pula.
Okay.
Doktor, attendance ada doktor?
Oh ya, attendance kejap. Attendance saya belum buat ya. Alright. Saya buat lepas ni. So nanti boleh isi ya attendance.
Okay.
Okay, so kalau tak ada apa-apa, maybe I can dismiss this class. So anything about the exercise and juga tentang yang 2 chapter ni boleh tanya dekat group lah kalau ada question ya.
Okay.
Okay, baik. Terima kasih semua. Assalamualaikum. Selamat malam.
Selamat malam. Thank you.
Doktor.
Terima kasih, doktor.
Thank you, Doktor.
Kita cerita.
Bye.
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 Bye.